This is CT6, yeah, an old exam, right? CT6 April 2011. Question number 7. They're pretty similar though, right? So we can go a bit faster. You can work through them on your own, but never mind. Let me just breeze through it quickly, right? You have a time series. Can you see? YT is 0.7 plus 0.4 YT minus 1. Looks the same, right? Just the numbers are different. 0.12 YT minus 2 and ET is the white noise process and the variance of sigma squared. Identify the model as an ARIMA PDQ process. Okay. Assuming stationarity, right? Okay. Assuming that we have a stationary process, the model is ARIMA 200. This is, remember, we had the same example just now. Okay. So we have ARIMA 200. Okay. So we are assuming this process is stationary. Don't worry about it, right? We will show stationarity in a minute, but since they've worded the question like this, so we can write it's ARIMA 200. Then, like just now, the characteristic equation. Okay, the characteristic equation will be 1 minus 0.4 lambda minus 0.12 lambda squared. Okay. Okay, let me do that again here. Okay, you will have YT minus 0.4 YT minus 1 minus 0.12 YT minus 2 equals 0.7 plus ET, right? So we are just looking at the AR part. Okay, looking at the AR part, you can write your characteristic equation, okay, which is 1 minus 0.4 lambda minus 0.12 lambda squared. So basically, you have to solve this quadratic equation. Solving a quadratic equation, right, is very easy for us, right? Okay, we are mathematicians, so for us, it's very easy to solve a quadratic equation. Just use the formula, and you have a calculator that can do wonders for you. Okay, you can plug in all the values of your coefficients and solve the quadratic really quickly and check that you have the correct answer. Okay, so when you do that, okay, this I've used minus b plus or minus b squared minus 4ac over 2a, okay, and I get my roots. So we have, since the roots have magnitude bigger than 1, okay, we have minus 5 and 1.6667, the process is stationary. Great. So the expected value of YT, you can do that on your own. Okay, you can pause the screen. I mean, it's exactly like what we did just now. So we can save some time because we are dealing with a stationary process. Okay, we are dealing with a stationary process. So the expected value of YT is the same as the expected value of YT minus 1. It's the same expected value of YT minus 2. Yeah, we'll just call them mu, right? It's a constant mean. And the expected value of ET, okay, the expected value of your white noise process is 0. So you plug those in, okay, you plug those in and you can solve for mu, okay? So I've done it. I've plugged in mu equal to 0.7 plus 0.4 mu plus 0.12 mu, okay? Okay, 0.7 plus 0.4 mu plus 0.12 mu. Solve for mu and you'll get some number there, as you can see. Okay, good. So now that we are done with that, let's deal with the next part. So what did the question want us to do? Let me look at the question. They ask you to calculate row 1, row 2, row 3, and row 4. So just be confident, yeah? We've already done it, right? So just work like we did earlier. They ask you to find more things, row 1, row 2, row 3, and row 4. So let's just look at what I've done. Gamma 1, right? Okay, let me just go through the lines here. Gamma 1 here is the covariance YT, comma, YT minus 1. So I've just written, if you look at the question, I didn't bother writing the 0.7, right? Because it's not going to affect me in any way. So I just wrote 0.4 YT minus 1 plus 0.12 YT minus 2 plus ET, right? For the left-hand side, right? So let me just put a little bracket here. Okay. And this one is what you see here. Then what do? I wrote a note there, right? I've ignored the 0.7 because it doesn't affect my calculations. Okay, it's a constant. So once you have done that, you're pretty much on a roll now. Okay, so let's see. Okay, so you look at your terms here. You take this term and this term. Okay, this is t minus 1 and this t is t minus 1. So you'll get 0.4 gamma naught, right? Then you go to the next one, 0.12 here and this one here. So t minus 1 minus t minus 2, we have gamma 1. You get this. Okay, so gamma 1 is 0.4 gamma naught plus 0.12. Okay, gamma 1. This and this, it's 0, so it doesn't bother us, right? We have said that before. This is a past observation. This is your present error. Okay, so the logic is all the same. You go to gamma 2. Okay, write this out. Write down your expression here, your process, and then do the same thing. Take 0.4 yt minus 1. Okay, and yt minus 2. Let me do that one more time. Okay, you will get 0.4 gamma 1, and then you take this thing and you deal with this. This is t minus 2 and t minus 2, so you get 0.12 gamma naught. Okay, so you have equation 1, equation 2, set up equation 3. Okay, you can do it on your own. You'll get this, and then equation 3 is for gamma 3, right? And then we have gamma 4 is this. These things you can do on your own. So I let you do that. Pause the screen and make sure that you arrive at the same answers as I have. And once you're done with that, right, basically you are done, because we know gamma k over gamma naught, right? We know gamma k over gamma naught. That's my rho k, right? So just do it slowly. Okay, do it slowly. And you'll be able to hammer all the answers out, right? So we have just use all the equations that I have on top. Write it yourself. Try, if you can do it. I have written a little bit more than necessary. Like gamma 3 and gamma 4, I didn't. I thought you can do it yourself. And then rho 1, okay, from equation 1, you can get, right, this thing here. Okay, your equation 1, you get this. Okay, we have gamma 1 is, look it up, right? Equation 1 gamma 1 equals to 0.4 gamma naught plus 0.12 gamma 1, right? So I'm looking at my answer in my hand, right? So you can clean this up a little bit and you'll get, can you see this one and this 0.12, you can already see the 0.88. Clean that up and you'll get this. So, when you look at this, right, straight away, you know the value of rho 1. Okay, 5/11. So do the same, a bit of working to do, no big deal. Use equation number 2, equation number 3. I'm trying to get gamma 2 in terms of gamma naught, gamma 3 in terms of gamma naught, gamma 4 in terms of gamma naught. I can write my rho 2, rho 3, rho 4, and I'm done. Pretty good, right? So I hope you like questions like this. Just don't make any careless, when you make careless mistakes, right? Be careful.